So without further ado, a lot of times when I do moderation, I kind of like abbreviate the bio so we can get right into the content. But these are two thought leaders, so I want to give them the full treatment here. So first we have Larry Weis, and he's the general manager at Austin Energy. And he joined Austin Energy in September of 2010 and has more than 3 decades of experience in the electric and water utility industries, and more specifically, publicly owned utilities. He spent 10 years as general manager of an irrigation district in California and another decade in managing utility districts in Washington State. He serves or has served on boards for a number of associations and national and regional joint action agencies within the utility industry and on private corporation boards. He is considered an expert in strategic planning within the utility industry, and he is a graduate of the School of Sciences and Technology at Western Washington University. Go Vikings. Without further ado, here's Larry Weis. Give him a round of applause.
Uh-oh, feedback. Good evening. Am I okay audio-wise, or do I need to use, we all right? Okay, good. Nobody likes that feedback. If you don't mind, I'm going to stand out here, and thank you for having me, and welcome to Austin. I understand a lot of times when I talk, it's an all Austin audience. I don't think that's the case tonight. I think we have people from a lot of places, and so I better talk about Austin Energy a little bit and who we are and what we are. And I get this question sometimes. They say, well, what is the general manager of a public utility about? What do you do? And I say, well, I'm actually the CEO. And in our industry, nationwide in the United States, municipally owned electric utilities, electric cooperatives, and a variety of other forms of publicly owned utilities use that title as their CEO, so just wanted to clarify that. Well, let's get on to talking about the future a little bit. I always like to do it. As Jim talked about, I've been in the business a while, since I think I was in high school, and the reality of it is that it's changed a lot, and it keeps changing, and it keeps changing, and it keeps changing. But Newtonian physics hasn't changed too much. We still need a product that delivers everything we need, and we need it reliably, and we need it at an affordable cost. And with that, we apply all the technology we have today, and kaboom, here's where we are today. So let's go into it a little bit. About Austin Energy, we have a mission of delivering clean, affordable, and reliable energy, excellent customer service. We're the 8th largest publicly owned utility in the United States. When we say community owned, that's one and the same. We serve several cities besides Austin here. Our service area is 50% of it's the city of Austin, the other 50% is outside the city of Austin. So we serve the city of Lakeway and parts of towns around the north of us and so forth. We have about 440,000 customers and counting. All of those cranes and all those buildings will have meters, and there will be more customers coming. When I came here in 2010, if I remember right, I think we were around 410,000 customers. And so it just keeps cranking along. And one of the interesting things is that our residential use is per meter is going down, and that's because we have smaller and smaller homes, and our energy efficiency is working, and a variety of other things are working. So very interesting. I won't go over the rest of the stuff, but that's who we are. And we have some very ambitious goals that were put in place recently. We have a goal of being 55% renewable by 2025. And we have all of these other goals that we've been working on. But we have to be competitive and affordable. Limited to a policy of 2% increases in our rates per year, and also want to be in the lower 50% of retail rates within the state of Texas, within the ERCOT region in particular. So we can't do anything we want. We still need to be cost conscious, and we need to be cognizant of our industry and making sure that we have affordable rates. And we have some items that we'll talk about in our new goals, like local storage. I'll talk about storage quite a bit tonight. And I know that a lot of utilities are looking at this across the country. Utility scale solar, we have an RFP that will come out very soon for another 600 megawatts of utility scale solar. We just executed one for 150 to the company Recurrent. And that will be online next year in West Texas. So a lot of ambitious goals. A net zero beyond 2025, and there may be a limit to the amount of large-scale renewable that we can hear. The analysis shows that 55% renewables, greater than that, will have started to erode our economics. And I won't go into that tonight, but that's our analysis. And we've become a large net seller of those resources into the market. So in ERCOT, which the United States or North America used to be sort of like back in the 80s, used to be pretty much the same everywhere. But now we have reliability regions that have become more defined. We have markets that have become more defined. And these markets are unique. What works in a market in California does not work in a market in Texas. What might work here or other places. So as you work in your industry or whatever you do, you have to think about that. You need to think about how those markets work uniquely and differently in other parts of North America, frankly. And there is a balance sheet limit to our purchase power agreements that we can put on. So we generally don't go out and construct and operate these renewable projects ourselves. We typically buy the energy from the developer. And the future of energy solutions by 2025 will require local system changes. I'll go into that a little bit. This is a map of our solar customers. These are retail, these are consumer-owned solar systems. I can tell you that when I came here 5 years ago, I think about 25% of those dots were only, 75% of those dots weren't there, okay? That's how much it's grown. It's amazing. And to give you a perspective, the line outside of that border line is our service area, and the tan, I'm a little colorblind, I think it's tan, that's the city of Austin's city limits. So you can see that the area out around that is what we also serve. We've all talked about the interesting phenomena of the distribution systems in the United States that have had a lot of solar penetration. So for the electrical engineers in the room that work on the T&D side and the protection side, protection scheming and everything that we do in a distribution system, we want to maintain good voltage, good frequency. We don't want a lot of harmonics. We want a pure, power quality. Remember that word? We'd like to have quality power delivered to customers. Well, here's what's happening, and I think everybody recognizes it, but we have a lot of interesting disruptions that are happening on the system. This example below is the impact of a 2.3 megawatt solar PV array on a 12 kV distribution feeder. And the demand without the solar and the customer demand with solar, and this up and down and this phenomenon that's happening is something that we're monitoring a lot. This is where storage is starting to come in for us, and storage is being used for other techniques, and we'll get into that a little bit. The benefits of microgrids is that we can operate autonomously on a local level. And let me give you an idea about this. So we have about 90 substations in our service area, and the feasibility is that we can take one of our substations completely off the grid. No transmission feeder to it whatsoever, and we can provide that. We've charged the batteries in it or whatever the device is, and I won't go into that too much tonight because I'm not sure it's always going to be batteries, because I've been involved in fuel cells and a variety of other things. But the idea is that we can isolate a substation and we can provide the service to the customers, and the customers themselves can provide a regeneration feed from the PV systems that are inside that are feeding that substation. So that's the engineering level stuff that we're doing on, and we have some real projects, and we're going to be talking about those in a minute. The potential for improved reliability, peak times and outages, weather events of microgrids is very interesting. So as we look at the future of it and the economics of it, there's just a lot of things that can be done. and it counteracts the impacts of solar fluctuations. So I think that's where we kind of all started. We said we've got overgeneration in our distribution system. What can we do with it? And it's essentially like taking an electric circuit and putting a battery in there in the circuit, and a lot of things change. I always use the analogy of, for anybody who's a sailor in here, sailboats. You know, sailboats are probably one of the most renewable things that we have, and we don't even really recognize that. We got a battery pack in there, we got storage, and a lot of them have wind generators and solar. Now they have a diesel engine, all right? You don't want to get into rocks. But the reality of it is that it's a very interesting parallel to some of the things that we talk about being autonomous. And it allows, fundamentally, it allows energy storage to be a practical tool. I know my next speaker, I've heard what some of Don's stuff he's talk about. It's very fascinating what they're looking at Encore. Austin Energy microgrid use cases is we have a community solar project that is underway. And we will have a distributed solar and energy storage at the substation behind the meter. And we have net zero design homes and new substation with grid batteries as a part of the design. So our solar and our energy storage at shopping complexes with big retail boxes. So there's a lot of applications that we're starting to look at. And it really kind of started, frankly, with the opportunities of the lithium ion and the opportunities of having cars used as a source, and all of that thinking is really where it's come to. Let's talk about our journey at Austin Energy. We have, since 1982, we've had energy efficiency programs and the value there is that the first and cheapest energy that we can generate for ourselves is that we can save off of our customers with energy efficiency programs. And typically we work a lot on coincidental peak reduction, demand side savings. In '85, we got into transmission SCADA, and fiber came along, and automated meter reading and green choice. And I won't go through it all, you can read it, but it's a very fascinating history, and it's really not about smart grid anymore. It's about being a smart utility. It's about being a smart utility, and it's about having it wrapped around your business model. So you have a business model. I talked about being affordable, reliable, all of those components. And this smart utility journey is just really starting, I think. It's really going to be fascinating to see what the future holds. Let's talk about our pilot project. We own this land. It's called the Kingsbury Substation, and it's the first known utility-scale storage solar project in Texas, 2.3 megawatts. And it'll have a 1.6 megawatt lithium ion battery system, and it'll be online the fall of this year. And that'll give us our first toys to play with, frankly. And I'm really excited about it. The pilot project of distributed solar and community solar and grid storage and customer storage, the combination of all of it is another project that we're working on. All-in cost of $10 million. And we'll maximize the value of the storage and smart inverters to customer and utility. And it's a 3-year project, and the awards will be announced in June for this grant that's happening with the Department of Energy. So again, I won't go through all of the words up there in the slide. I do believe that we'll be successful in getting that grant and trying to achieve some of these interesting objectives that we have. In the shift to a smarter utility, one of the things that isn't on this slide that I find interesting, and I'll be talking at really a purely engineering conference in Chicago this year, is the talent that we need to do this, okay? The talent that we need to do this. It's no longer a business of engineers and accountants. It's a business of IT, and it's a business of a lot of different disciplines. And it's attracting, the utility business used to be kind of boring. And now with all of the tools and the things that we're doing, we have a new crowd. I'm looking at a lot of you that are pretty enthusiastic about what's happening with this industry. And it's going to be very, provide a lot of career challenge and a lot of opportunity, I believe. But shifting to this smarter model will also have customer and community benefits. And I talked about the employees, but there'll be some really interesting synergies with our customers as we continue to move along. I want to thank you. Oops, I got to go back here. And it seems like I shifted off of a slide. But I want to depart by showing you a little video. And I want to tell you that I'm going to qualify at the beginning that it does not meet all of the safety requirements from my eyes. All right? But if we could play the video, sir, please. And I thank you for, and I'll look forward to your questions and so forth.
(1713) to base, standing by AE 1914.
If everybody checks in the clear, we'll come close with an AE 1914 breaker.
We are in the clear. You're going to close AE 1914.
10-4, come close with that AE 1914 breaker. Distributed energy from a battery.
Yep, that's the future.